Electron displacement effects in covalent bonds. Let us first discuss about inductive effect. What is meant by inductive effect? It refers to the polarization of sigma bond caused by the polarization of adjacent sigma bond. So if there is a polar sigma bond, it will cause the polarization of an adjacent sigma bond, and it is known as inductive effect. For example, consider chloroethane CH3CH2Cl. We know that carbon-chlorine bond is polar, with chlorine forming the negative end and carbon forming the positive end. So the CCl bond is a polar covalent bond, and carbon 1 gains some positive charge and chlorine some negative charge. Since carbon 1 gains some positive charge, it will draw some electron density towards it from the adjacent carbon-carbon bond or the CC bond. So now some positive charge will develop on carbon 2 also. So such polarization of sigma bond caused by the polarization of adjacent sigma bond is known as inductive effect. Inductive effect is related to the ability of substituents to either withdraw or donate electron density to the attached carbon atom. Therefore, substituents are of two types: electron withdrawing groups and electron donating groups. Electron withdrawing groups are halogens, nitro group NO2, CN, carboxylic acid group COH, and ester group COOR. Various electron donating groups are alkyl groups like methyl, ethyl, etc. Resonance structure. We know that if more than one Lewis structure can be drawn for a molecule, then the actual molecule is taken as a resonance hybrid of the various canonical structures possible. For example, consider benzene. Two different structures possible for benzene are shown here. So the actual benzene molecule will be a resonance hybrid. Now consider nitromethane CH3NO2. Two different structures are possible for nitromethane, and actual molecule is taken as a resonance hybrid. Next we shall discuss about resonance effect. It is also known as mesomeric effect. Let us see what is meant by resonance effect. It is defined as the polarity produced in the molecule by the interaction of two pi bonds or between a pi bond and a lone pair of electrons present on an adjacent atom. The effect is transmitted through the chain. There are two types of resonance or mesomeric effect designated as R or M effect. So what is meant by resonance effect? It is defined as the polarity produced in the molecule. Polarity produced in the molecule means one end of the molecule will be positive and the other end of the molecule will be negative. And how is the polarity produced in the molecule? It may be produced either by the interaction of two pi bonds. As a result of interaction of two pi bonds, polarity may be produced in the molecule. Another way by which polarity is produced is by the interaction of pi bond and a lone pair of electrons. So as a result of interaction of two pi bonds or by the interaction of a pi bond with lone pair of electrons, polarity may be produced in the molecule. And this effect is known as resonance effect or mesomeric effect. What is meant by positive resonance effect or plus R effect? In this effect, the transfer of electrons is away from an atom or substituent group attached to the conjugated system. This electron displacement makes certain positions in the molecule of high electron densities. This effect in aniline is shown. So here consider aniline C6H5NH2. Nitrogen has a lone pair of electrons. So in positive resonance effect, the lone pair of electrons which is present on nitrogen shifts, as a result of which carbon-nitrogen bond becomes double bond, and when the lone pair of electrons present on nitrogen get shifted, there will be simultaneous shifting of the pi electrons present in benzene ring to the ortho position. So the transfer of electrons is away from an atom or group attached to the conjugated system. Benzene ring is taken as the conjugated system here. And the transfer of electrons is away from the group, NH2 group attached to the benzene ring. As a result of shifting of the lone pair of electrons present on nitrogen to the adjacent bond position, we get the next structure in which nitrogen carries a positive charge and the ortho position carries a negative charge. Thus, we find that polarity is produced in the molecule. Nitrogen end is positive and carbon end of the benzene ring acquires a negative charge. So this polarity is produced by the transfer of electrons away from the group attached to the benzene ring. So this is why it is known as positive resonance effect. Now consider the second structure shown here. We can show further movement of the electrons. That is, the electron pair which is present at the ortho position will now move to the adjacent bond and there it makes a double bond, as a result of which the pi electrons in the benzene ring will get shifted to the para position. The para position as a result of this will acquire a negative charge. So that is how we get the third structure. From the para position, the electron pair may now move to the next bond position. There we get a double bond, as a result of which the pi electrons move to the ortho corner. And the ortho corner will now develop a negative charge. So these are the various structures possible. And in these structures, we find that the ortho and the para positions have become comparatively electron rich.